In this video, we will be going over the Bernoulli equation. So the Bernoulli equation, or Bernoulli differential equation, is just an extension of the linear differential equation. So the linear differential equation, as we went over in the last video, has the form y prime t plus pt yt equals gt. And then in order to solve for the solution yt, we would need to first get an integrating factor, which was mu t, and then that would be e to the power of the integral pt dt. And then in order to get yt, you would just do 1 over mu t, and then integral of mu t gt, and then dt plus c, right? That's how you would get your solution. But now the Bernoulli differential equation is basically just an extension of the linear differential equation. So it's like an added step. That's all it is. And the Bernoulli differential equation has the form y prime x, and I'm just changing the t to the x just to be a little bit more clear that it's different from the linear differential equation. So yeah, y prime x plus px y x is equal to gx multiplied by yx to the power of n. Okay, so this may look a little bit unknowing, because now if you look at the difference between the linear differential equation and the Bernoulli, the difference is this thing, right? This y to the n. So how do we solve it now? Well, you have to do a little bit of trickery. You have to do some math magic. So you have to multiply both sides by 1 minus n y to the minus n. Okay? And then once you've done that, then you want to group let's move this over here. Then group such that you have some variable v that is equal to y to the minus n, and then you take the derivative of v, and v is in terms of y, so maybe I should be more clear. So v is in terms of y to the 1 minus n, and then we take the derivative of v, and the derivative would be 1 minus n y to the minus n y prime. Okay, and again in this case y is yx, just to be more clear. So yeah, so now let's do an example. Okay, let's do an example. So this example that I'm about to show you is going to be essentially, you will see in a moment how we first have a Bernoulli differential equation, but then after doing these steps, so like multiplying by 1 minus n y to the minus n and then substituting v's in, we will get a linear differential equation where instead of having y, we will have v as the function, the unknown function. And then you would solve that equation like a linear differential equation, plug the relation between v and y at the very last step, and that's how you would get your solution as y in terms of x instead of v in terms of x. You will see in a moment. Okay, So let's do that. So, example. X, y prime. Here, solve x, y prime plus y plus 4 x squared y squared equals 0, y is greater than 0. So then, as always, please go ahead, try this, and then we will try and solve it. Okay, I'm hoping you've tried it and now you've come back. All right, so let's get to it. So first thing we want to do is we want to put it in the form of a Bernoulli equation. So we're going to have y prime plus y, and then I'm just going to move this term here to the right side, and now I'm going to divide everything by x. And actually, let me write the y in terms of x, just to be very clear. Yx minus 4, and then you would divide, so then that would just be x, and then you would have yx squared. Okay, and so now what we want to do is we want to bring the denominator, the y in the denominator, up, just to be clear. So y x to the minus 2. So as here, as I mentioned, first thing we want to do is we want to multiply both sides by 1 minus n y to the minus n, and I should probably put a line here just to, yeah, okay. So multiply both sides by, step 1, multiply both sides by 1 minus n y to the minus n. So that means that our n, based on the equation, was whatever the coefficient up here was, right? So in this case, that's minus 2, right? And so that means that we're going to say n equals minus 2, and so then we're going to call this the multiplier is 1 minus n, so then that's 3, right? Because I should be more clear. 1 minus negative 2 y to the minus negative 2 equals 3 y squared. Okay, so we want to multiply both sides by 3y squared. So let's do that. So 3y squared, y, actually, hold on. Let me use the magic of technology. Okay, so again, let me be more clear. This y is in terms of x, all right, because y equals yx in this case, based on the equation. So let's do this. So let's multiply this side by 3 yx squared, and then let's also multiply this side by 3yx squared. So then, as you can see, these two will cancel, and then you're left with minus 12x 3, and I'm not gonna write the y to the x, I'm just gonna write y. So 3y squared y prime plus 1x, 3y squared x y. So yeah, that's what you end up with. Now the second step was up here. So we multiplied both sides by 1 minus n y to the minus n, and then you want to group. and you're substituting v for y. So let's do this. Let's bring this thing onto the next page, like so, and then 2 multiply, sorry, what am I saying? Substitute v as y, and what was it? Let's see. V as 1 minus n. N was -2. So your Vy, this guy right here, your Vy is going to be y to the 3. So let's do that. Y to the 3. And then yeah, so then your V prime, and okay, let me be very clear. So V is in terms of y, right? So Vy is y cubed. And so when we take the derivative of this, right, we get 3y squared y prime. Okay? And so now, as you can see, this term is v prime y, and then 3y squared y, well, okay, 3y squared y, this we can rewrite, this is y cubed, okay? So this, right, because we had a y squared and a y, so that's y cubed. So then you get 3 to the x, and then vy minus 12x. So now this resembles a linear differential equation. Right? Because recall that a linear differential equation has the form y prime t plus pt yt equals gt, right? And so while the v might not be y, right, you can still say that v is technically y, or it is some different way of expressing y, because we have y cubed, so we substituted it in. So this resembles a linear differential equation. So we can solve it as a linear differential equation. And so then your mu x, recall, was something like e to the power of integral pt dt. Well, okay, we don't have p in terms of t, we have it in terms of x, right? So then what's going to happen is it's going to be in terms of x. So you could write this in terms of px dx, just to be very clear. It doesn't make too big of a difference in this case, but it's always good to be clear. Anyways, so it's 3 to the x and then dx, and then that gives you e to the 3 ln x, and then e to the ln x cubed, right? Because we can just bring this 3 in here, and then anything e to the ln will always just be whatever's inside the ln, will be the argument of ln. So then that's just x cubed. So your mu x is just x cubed. Okay? And so then your final answer is not yt, it's vy, because that's the unknown function. Vy 1 over the mu, which is x cubed, integral of mu x cubed, and gt, or gx in this case, minus 12x dx plus c. So then you can bring this 12 out, you combine the x's, that's x to the 4 dx plus c, 1 over x cubed. So then this is minus 12 over 5 x to the power of 5 c 1 over x cubed, which we can rewrite as minus 12 over 5 x squared plus c x to the minus third. And that is, these are all Vy. Yeah. Okay, so then we now know what our Vy is, right? It's this thing. And that's great, but now you want the solution in terms of just y, right? Because, or yx. So then remember that, let's pick a different color, let's pick pink. So remember that v is y cubed. V is y cubed. So then we're going to use this fact, and we're going to express v in terms of y. So then we know that since v equals y cubed, that's y. And recall that y was in terms of x, right? So yx, this is cubed minus 12 to the 5x squared plus cx minus 3. So then yx minus 12 over 5 x squared cx minus 3 1/3, because we did that. So then this just becomes 1. So yeah, that is your y. So again, a Bernoulli equation is an extension of a linear differential equation. And you have to, there's what, 2-3 extra steps, right? You gotta multiply both sides by 1 minus n, y to the minus n. Then you gotta substitute v as whatever v as y to the 1 minus n. And then you have to take the derivative, and then that will allow you to turn that Bernoulli differential equation into a linear differential equation. And then you can solve it just like a linear differential equation, like how we did in the last videos, or in the last video. And yeah, it's just an extra 2 steps. That's all for this video. Thank you for watching. If you have any questions, please put them down in the comments below. I'll be happy to answer them. Goodbye for now.